They say space is the next frontier, but to truly live among the stars, we might need to look for a solution beneath us, in the ocean. One of those solutions could be cetaceans, the group of marine mammals known as whales, dolphins, and porpoises. Their ancestors were once land-dwelling, and because of their terrestrial background, their skeleton may be more similar to ours than you may realize. They have a bony skeleton made of two different types of bone, a solid compact bone on the outside and a spongy type on the inside called trabecular bone. Trabecular bone is extremely important because it's dynamic, meaning it responds to the forces it experiences. In you and me, our trabecular bone will respond and rebuild its structure to support our body's movements against gravity. But what happens in an environment with minimal gravity? This is the exact problem our astronauts face, and their bones deteriorate due to the lack of normal forces to rebuild their bone structure. Houston, we have a problem. Where do we go from here? Well, I might know a way to study bone in a comparable environment. That solution, the cetaceans. Whales, dolphins, and porpoises experience minimal gravitational loading due to the buoyancy of water. So what does their trabecular structure look like? That's the exact question I aim to answer. To do so, I'm using a method called micro-CT scanning, which uses three-dimensional X-rays to image the inside of a specimen. Then I can quantify the amount and the 3D arrangement of the trabecular bone. Now, cetaceans all live in the water. You think their bone might look the same, right? Not quite. I've examined nearly 30 species of cetaceans and am finding that their trabecular bone varies by their lifestyle. Think about a small porpoise that navigates coastal waters, or a dolphin out in the vast open ocean, or even a large whale that glides down to the depths. All of these swim a little differently, and that variation is reflected in their trabecular bone structure. These results are extremely important because it's teaching us more about the relationship between bone form, or how it's shaped, and its function, how it responds to loads. Now, this research is actually multi-purpose, because not only can we examine the evolutionary progression of cetaceans into diverse habitats, but it also serves as a model for future bone loss. My research is laying the groundwork to examine the natural variation in bone structure, and future studies will be able to minimize bone loss in microgravity environments. However, I think a bigger impact of this research is understanding the limits of bone. The photo you see at the top is a vertebra of a whale that was struck by a boat so hard it shattered its vertebral column. My research on bone structure will inform us more about the breaking point of bone and hopefully prevent scenarios like this. It's my hope that my dissertation will not only save sensitive whale species, but help keep our astronaut bones strong. After all, it's one small step for me and one giant leap for whale kind. Thank you.